Hi everyone, we're Team 4. We have the Xilinx project. It's basically a camera development on an FPGA.
Alright, well, basically our objective.
Can you say your name first, please?
My name is Khan. Okay. And our project overview, basically we're trying to do a driver assistant camera, which everybody kind of knows, like these days, new modern cars, you have those reverse system and you have this camera on there. And basically we have, of course, our sponsors from Xilinx, who's have a lot of experience developing FPGAs and a lot of other hardwares. The hardware we have is we're going to have a car-mounted camera, but basically a camera and just grab the input, and a Xilinx FPGA board, which we're going to talk in detail in a bit. And the software is going to be the ISE design suite, and which is a FPGA design suite, and the MATLAB, and we're going to talk about why we use MATLAB in a bit too. And of course, this is a continuous project from last semester. So our goal for this semester is going to be majorly improving over what the last semester did on the existing hardware. And we are trying to do objective detection in real time. Okay, of course, like I said, this is a continuous project from last semester. So this is kind of the thing they did in Team 3 in fall 10. What they did skin detection, and they used a sober filter to find the intensity of an individual picture of a still image to determine the edges and to do edge detection. And of course, I think they used a function within the edge detection and a feature of the edge detection, and then try to highlight skins and to achieve human detection. Well, this kind of still working on the still image. And of course they tried object detection, but according to our documents, they did not accomplish it during the time string. But any of this would have a little issue, but I mean the most successful thing they did was edge detection. But the thing is they only did it on still image, and they have a manually set threshold. So if the lighting change or the environment change, you have to manually go there and set the threshold, so it doesn't work in real time, and it's a still image. And so does the skin detection. The skin detection works along with the edge detection. It works, but it makes a lot of false detection, so it doesn't really do much. And of course, the object detection, there's not really a lot of going on in there, because they said the FPGA doesn't support some high-level programming, and I don't think. And we tried to look at the FPGA. We think they did not use the fully ability of the FPGA, because basically they did not do parallel programming, and which is one of the things FPGA is good for. So within that, so we thought about some ideas, and we studied them, and so basically we decided we're not gonna use a lot of stuff from last semester, but we're gonna do some new algorithm and try new things with the FPGA. So should go actually, he's gonna take it from there.
Hi. Okay.
Your name?
I'm Min Chao, and this is our fast library for our project. And our main goal of our project is trying to provide Xilinx, which is our sponsor, with a new functionality to their hardware. And our focus in trying to visually assist driver, which is this block here. And in order to achieve this goal, we are trying to create a new algorithm which can detect object and also indicate the object on display by putting a little box around it. So we can alarm a driver while they are driving, which is this block here. And the solution we got for detections, we are trying to use a managed memory with sliding windows. And in a window, we're going to compute the HOG and also classify the object with support vector machine. All this algorithm is going to cover by John later on, so I can go just give you an idea about it. And after that, we're going to use all our algorithms and implement into our hardware, which is our FPGA board. and general universal P core on it. Okay, and for the hardware we're going to use for the project is a Silence Button 3A FPGA video starter kit. And the reason we're going to use it is because, well, it was provided by Silence, of course. And that's the only board we have, so we're going to use it after all. But besides this reason, there are still a couple advantages by using this FPGA board, such as it has a relatively smaller size compared to other systems, such as a PC platform. And it also has a lower power consumption, and also could be reconfigurable by the user by using the HDL. And the main advantage by using FPGA is that it has parallel architecture. This is meaning like the beauty about this is that it can actually run like multiple data at the same time. For instance, let's say if I'm going to process an image by using a standard microcontroller, maybe I can only process one pixel at one time. But if I'm using FPGA board, I can actually process like multiple data at the same time, which can accelerate my processing time. And usually for the image processing, the algorithm usually take a lot of computations. So it might, by using this, can actually save a lot of time and achieve a goal to running our things in real time. And for the camera we are using, it's just a conventional and cheap camera, which supports 640x480 resolution on it. And for the project, we're also trying to use additional cameras, such as a Z camera and infrared camera, just for easier detections. But we found out our board, the board we are using can only support one input source, but since it has two input port, but it's actually only designed for running for one input source. So if we want to use additional input source, we have to reconfigure the board first. And it's due to a limited time. It's due to a limited time of doing the project. So we decided to just use one camera, and things like using the other one, it might be impractical. But spend too much time, I just reconfigure the board.
All right. I'm Josh Frankfurt. I wanted to talk about the software that we're using. For a long time, FPGAs were developed just using the Xilinx software and using just a high-level design or a hardware design solution. So what people would do is you have to map out the entire transistor layout using the Xilinx software. So you would go in and code a lot of VHDL. So you'd be writing tons and tons of files to be able to map all the ports that you want from the bus into your cores. You would have to push all that information down a line. You would have to go in, do all your math with adders, subtractors, multipliers. To do loops takes several kinds of gates and logic to be able to accomplish this. So we were trying to figure out how are we going to simplify our design so that we don't spend more time actually doing gate level design than we are doing software implementation. Because our goals are pretty advanced, we want to implement a full machine learning algorithm. So doing that in hardware is a little tough. So we needed to find a couple ways to advance our development. So we're going to use MATLAB to use this graphical interface to do our layout. So you can see in here, this would be a type of P-core, which we'll explain later. But instead of using VHDL to manually type out the connections and all of these, we're going to just put blocks into Simulink and connect them down the line. And each one of these has a sublayer inside of it with the hardware design where you can connect all the gates to do your math. So we're using MATLAB and Simulink instead of just the ISE design suite. And from Simulink, we're going to be able to use the Xilinx system generator to synthesize our entire project instead of doing it with just the Xilinx software. the other advantages of using MATLAB is we have a SVM toolbox, which is for support vector machines, so that we don't have to write our own.